In this lesson, we're going to look at how to solve exponential equations. That is, an equation where the variable is in the exponent. There are two kinds we're going to look at. One where both sides can be written as the same base, and another kind where the two sides cannot be written as the same base. So here's a strategy for the first type. In order to solve like base equations, the first thing you want to do is write both sides with the same base. Then we know that if two equal things have the same base, then their exponents must also be the same. So we're going to write a little equation with the exponents set equal to each other and solve it. Here's our first example. 2 to the x plus 5 equals 2 to the 3x minus 7. Notice that both sides have the same base. Well, if 2 to this power equals 2 to that power, the powers must be the same as well. So we can write x plus 5 equals 3x minus 7. And we'll solve this by subtracting x from both sides. And that will leave us with 5 equals 2x minus 7. And now we will add 7 to both sides, and we'll get 12 equals 2x, and we'll divide both sides by 2 and see x equals 6. Okay? Here is another example. Let's solve e to the 2x minus 5 equals e to the 6x plus 7. So, you know, e is an irrational number and maybe not familiar to you as much as a whole number would be, but it really doesn't matter what the base is because we're not interested in the base, we're only interested in making sure they're the same, and they are. So if e to this power equals e to that power, then this power and that power must be the same. So we'll write our equation, 2x minus 5 equals 6x plus 7, and we'll solve it. Here I have subtracted 2x from both sides, and now minus 7 on both sides gives us negative 12 equals 4x. Let's divide both sides by 4, and we'll have x equals negative 3. Here's our next example. 4 to the 2x minus 1 equals 8 to the x minus 4. Now 4 and 8 are not powers of each other, but 4 and 8 are both powers of 2. So I could write 4 as 2 to the second power, and we could write 8 as 2 to the third power. Okay, now, just to remind you what happens when you have an exponent raised to another exponent, is the exponents are supposed to be multiplied together. So in this step, you can see I've shown the exponents as being multiplied times each other. That's our power rule for exponents coming into play right there. The power rule for exponents says if you have a power raised to a power, then you multiply the exponents together. Okay, now they both have a base of 2. So if 2 to this power equals 2 to that power, then we can distribute on both sides and solve just like before. So for this one we come up with x equals negative 10. One more example. Here is 100 to the x minus 3 equals 1000 to the 2x plus 3. Now 1000 is not a power of 100, but both of these are powers of 10. So we write 10 squared, because 100 is 10 squared, so 10 squared to the x minus 3 equals 10 to the third to the 2x plus 3, because 1000 is equal to 10 to the third. Then we know that the exponents on both sides are supposed to be multiplied together. So it's going to be 10 to the 2 times x minus 3 equals 10 to the third times 2x plus 3. 10 to the 3 times 2x plus 3. Okay, now, if 10 to this power equals 10 to that power, the powers must be equal. So we distribute, and we subtract 2x from both sides, and we subtract 9 from both sides, and x equals negative 15 over 4.